Welcome to solverfy.
In this problem, we have a sphere of diameter 32 centimeters. It's charged up so that it has a voltage of 680 volts on the surface. And we assume that the voltage at some infinite distance away is 0. That's our reference point, or 0 point. And we're asked to find the radius, some radius, where the resulting voltage of the sphere, the potential, falls off all the way to 25 volts. So to do this, we can start with the expression for the voltage, for the potential due to a sphere, charged sphere. And that is V equals Q over 4 pi epsilon naught R. It's our V naught, actually. So we're going to solve for the total charge because we're going to need it a little bit later. So 4 pi epsilon naught. Yikes. So that's our Q. We can find a charge density, surface charge density, sigma, equal to Q over 4 pi R naught squared, where that's simply the radius. Let's give ourselves a little bit more space. So that's our sigma is going to be 4 pi epsilon naught R naught V naught over the area, 4 pi R naught squared. Okay. We get a lot of cancellation. So we have V naught epsilon naught over R naught. Plug in numbers at this point, 680 volts for the volt charge voltage, and our R naught is half the diameter. Here's an R naught. Oh, and it's worth, we probably should give this a different script. Let's call that R1. R1. R naught is the radius of the initial sphere. We're trying to find the charge on it. And we can plug these values in to get 3.76 times 10 to the negative 8 coulombs per meter squared. All right. So at this point now, actual charges on the sphere, we can locate the R naught value that results in 25 volts. Well, let's call it R1 rather. So starting again from the electric potential due to just a uniformly charged sphere, Q over 4 pi epsilon naught R. We can plug in our Q. We're left, and once we do that, you're going to be left with R1 V naught over R. Actually, this is R naught. This is the actual R naught of the sphere over the R we're trying to find. So R1, the R in which R1 is equal to 25 volts. This R1 is going to be R naught of the sphere, V naught over 25 volts, which is what we're trying to find. When we plug in those numbers, we have 4.352 meters. All right. So just to recap, we had to solve for the actual charge located on the sphere using the fact that we know it's what voltage is charged to. We did that. Once we got it, we used the voltage, the potential due to a charged sphere, Q over 4 pi epsilon naught V, or R. And we found which R would be required to have a voltage of 25 volts, some distance away. And that's it.